Hello and welcome to your first lesson. Today we are talking about arithmetic sequences, which forms part of your sequences and series in your grade 12 syllabus. What arithmetic sequences are that they are identified by having a common difference. So if you have a sequence which is basically a set of numbers where there's a number that comes after another number, etc., and you take the difference between subsequent terms or the difference between numbers that are next to each other, then those differences should be the same. Or if they are the same, then it is an arithmetic sequence. So what do we mean? So if we have a sequence like this, where we have the first term called term 1 or T1, and term 2 called T2, all the way up to some last term, and we want to figure out whether this is an arithmetic sequence or not, the first thing we will do is we will take the difference between subsequent terms, so terms that are next to each other. So term 2 minus term 1, term 3 minus term 2, term 4 minus term 3, term 5 minus term 4, and so on and so on. So here we'll have term 6 minus term 5, and we will only call this an arithmetic sequence if this difference, term 2 minus term 1, is equal to term 3 minus term 2, which must be equal to term 4 minus term 3, which must be equal to this, which must be equal to that. Then we will have something called a common difference, because all these differences are the same, they are common. Which means that if T2 minus T1 is equal to D, then T3 minus T2 will also be equal to the same D, and this will also be equal to the same D, this will also be equal to the same D, and so on. And we will call these D's the common difference. So if such a D exists, if we have a common difference, which in this case we do, common difference, then we have an arithmetic sequence. Therefore, this is arithmetic. But I mean, how do we apply this in practice? What does it mean? So just to put it into context with an example, if we have an example where we have the following sequence: -3 followed by a 0, followed by a 3, followed by a 6, followed by a 9, etc. And the question is this an arithmetic sequence? And if it is, or if it's not, whatever, find the next term. So is it an arithmetic sequence? That's the first question. And how do we find out whether it's an arithmetic sequence? It's the same set of steps. We find the difference between terms that are next to each other. So subsequent terms, 0 minus -3. So we know that 0 minus -3 is equal to 0 plus 3, because negative times negative is positive. So 0 plus 3 gives us, well, 3. So we end up with 3 here. And then 3 minus 0 is a 3. 6 minus 3 is a 3. 9 minus 6 is a 3. So we can see already that we do have a common difference. But why is this so important? Why do we need a common difference so much? We need a common difference because it allows us, or it helps us to find the next term. So what comes after 9 and what comes after the number after that. And how we do that is, if you look at this sequence here, we have a -3, But then if we add the common difference, negative 3 plus 3, we get 0. And if we, from 0 to get to the next term, we add the common difference 3, we get 3. And 3 plus 3 gives us 6. 6 plus 3 gives us 9. And we know, because we have a common difference, we know that we will have a common difference between 9 and the next term. And the next term and the term after that. So to find the next term, all we'll need is say 9 plus 3, which is going to give us 12. And to get the term after that, it's 12 plus 3, which gives us 15, and so on and so forth. So yes, we can find the missing terms using the common difference, which is why it's so important. D equals 3. But what happens if I ask you to find term number 2000? You don't want to go and add 3 multiples and multiple number of times, possibly thousands of times, just to find a specific number. Mathematics is about efficiency, and what we want, if we go back to the side, what we want is a function where we can plug in the position of the term, which is n, and it gives us the value of the term. So for example, we want to be able to say, if we want term number 3, we plug in 3 and we get the value of the term. In our example, that would be 3. But how do we develop such a thing? Just going to scroll down here a little. So if we say that our first term, if we let first term equals a, term 1 will be equal to a, of course, because we let it be a. Then term 2 is going to be a plus d, because we said we move from one term to the next, we add the common difference. So we know that d is the common difference, and we add it. To move from term 2 to term 3, we add the common difference to this, so we'll have a plus d, which is term 2, plus d to get term 3. So that gives us a plus 2d. And to get term 4, we have a plus, we add d to this, it's going to be a plus 3d. And we can see the pattern that to get the term number 4, we had 3 d's, so that's 4 minus 1 d's. To get term 3, we had 2 d's, which is 3 minus 1 d's. So to get term n, we have n minus 1 d's, because that's the pattern. So we have a plus n minus 1 d. And this is the kind of thing we're looking for, that generalizes the position of the term, and we can use that position to get the term itself. So if I go back and write this in the example that we have previously, if I come here and say Tn, or term number n, is equals to a plus n minus 1 d, which is going to be equal to, we know that a is the first term, in this case it's negative 3, plus n minus 1, and the common difference is 3. So then this is our general term. So Tn is equal to this. So now if I want to find term number 2000, all I need to do is substitute 2000 in here. So negative 3 plus n minus 1. Our n is 2000 minus 1 times 3, which is going to give us We just need to punch our calculator now and get the answer to the question. So 2000 minus 1 times 3 minus 3, and it gives us 1994. So we can see that the term in position 2000 is 1994. And that is the basic approach in sequences and series. In the next exercise, you will get to practice some of this, and your knowledge will be tested from this video, where you will be required to apply some of the things we discussed and do some calculations. The next lesson will be about quadratic sequences, where we have a second common difference. That means that the first difference is an arithmetic sequence itself. I will see you then.